this project we will need one old or broken CD or DVD-ROM drive, one Hall magnetic field sensor, one 10 kilo ohm potentiometer, a few jumper wires, a 5-volt DC power supply. I'm using an old mobile phone charger. We're going to need an Arduino Uno, and we are going to build a tachometer which will read the number of revolutions per minute of a small motor which we're going to get from the CD or DVD-ROM drive. So go and collect your components. Right, here we've got an old CD-ROM drive. I think it's 52 speed. I'm going to strip it down and I'm going to scrounge some parts so that we can work on our next project. I always save all these little screws because you never know when they're going to come in handy. I'm not really bothered about breaking it because, like I say, we're stripping it down for the parts. So. If you look there, there's an LED, a push button, potentiometer, 3.5mm headphone jack. There's actually quite a lot of parts that you can salvage out of a CD-ROM drive. Move those out of the way for now. Couple of stepper motors. What have we got here? All these components can be desoldered if need be. The parts that I am actually after for my next project are here. And I want to be careful that I don't break the pins off there, because what I'm after is the DC motor. There are 2 stepper motors, but it's the DC motor that I want. Doesn't really matter, does it? We'll check the date of manufacture on this thing. I've got a feeling that it is very old. Date of manufacture, June 1999. Right, as I said, the DC motor there is one of the parts that I want to harvest from this. I also want to harvest the laser, and while we're at it, I will have the stepper motors as well.
and I may also go for the potentiometer. Next I need to undo those two tiny little screws. Now, just be able to remove the PCB like so, without damaging any of the components. You can see how old it is. Look at all the dust. Obviously I haven't been using it for 10 plus years, so it was just sat in the cupboard as a spare. Okay, so what I shall do now is I shall unsolder these two pins. Seeing as I'm not going to need this ribbon connector, I shall cut it off. Okay, now that my soldering iron is heated up, I will attempt to unsolder this. I'm not too bothered about the board, I don't really need that. So. And there we have it, a DC motor, the pins still intact. Luckily the positive side was marked with that red dot. As you can see, just for now I've taken off the DC motor, this little switch, which I think was what told the CD drive that the drawer was closed, and this tiny little green LED. There are other parts that I'm going to take out of it, but we'll leave that for the next video. I'm just going to tin these two wires to make it easier to connect to the DC motor. I'm simply using this clamp as a way of holding wires still. Get a nice blob on that one. Next time we'll make sure that there is a spot of solder on each of these contacts for this motor. Like so. And then we will solder the positive one to the positive terminal. Like so. And the negative one to the negative terminal. Fiddly. Not the best soldering in the world, but for the purposes of this demonstration it will do. We've got our DC motor with a positive and negative wire connected. Okay. This black plastic assembly which sat underneath the circuit board that drove the motor, I've cut it off because it conveniently has mounting holes so that we can mount it to a piece of wood. I can also mount the motor in it, and if I use the rubber band that came on it, it will then spin this cog like so, and I can put using the glue gun, something on there. I'm going to fix this motor back in this plastic casing now. If I can get the holes to line up properly, there we go. And these ridiculously small screws go back in there. Should be able to get them in. Come on. This is where I could do with a piece of blue tack, but there we go. One screw and the advantage of having a magnetic screwdriver, kind of. There we go, 2 screws. So now the motor is now fixed back into this black plastic casing. The black plastic casing can be attached to a board, and we can put the elastic band back on the motor. Now when the motor spins, the cog will spin. Okay, a couple more items I've taken out of this old CD-ROM drive. There is a couple of neodymium magnets there that were in the laser array. There's actually, where the lens is, there is a couple of coils, and there's those 2 tiny magnets. But we are going to need those to complete our project. Okay, I've just been out into the garden and I've got myself a piece of wood to attach these down. There we go, we now have our frame mounted onto a piece of wood. The only reason I've done it this way and mounted it to a piece of wood is because we're going to have to glue a circular platter onto there, and then we are going to need to make a bracket of some description for the Hall magnetic field sensor to sit on, so that when this motor spins this platter, we will be able to read the number of revolutions per minute. Okay, I found something that we can put on top of there. I'm going to use that, which is a part out of a 3.5-inch hard drive that failed. It's actually the part that held the platter to the motor. But I've decided to use that because the magnets will stick to it, so it will make attaching the magnets for the Hall sensor to read a lot easier. Okay, I've just harvested another part from the CD-ROM drive. This did have a rubber washer like that in it, obviously to absorb any vibration from the spinning of the disc. But what we shall do with this is we will use the glue gun and we will glue it to there, and then that will provide some way for the platter to spin, and this central piece right in the middle where the screw goes in to stay still. We will put tiny splodge of glue on here, and apply our washer. Okay, I've just put plaster thing on top that we're going to stick our magnets to, and I shall now tighten it down. there we go. Now connected, and it spins freely because it is no longer binding onto the inner cog. Just a bit more. Okay, next thing's next. We need to attach the magnet to what we want to measure the RPM of this little plaster here. Now, one thing to note is there are two different types of magnetic Hall sensor. The one that we are using detects the magnet's north pole. The other type detects a magnet's north pole, and then it wants to detect the magnet's south pole to turn itself off. So we will affix the magnet to our little plaster. Now obviously, depending on what type of magnetic Hall sensor you've got, depends on how you have to configure your magnets to do this. Because I've got the one that detects the north pole of the magnet, I have checked to see which face of the magnet is north and which is south. The top one is north. So I am going to put a spot of glue on there and fix my magnet. There we go. Okay, now to make the bracket to hold the Hall sensor, I'm going to chop up some of the CD tray assembly. We need to have the Hall sensor mounted here so that we can pass the magnet underneath it every revolution. So I think I will just cut. The best way to do it, I think we should do it that way, and then I can mount it quite easily. Whatever way you figure out to do this, provided that there's not too much of a gap between the Hall sensor and the magnet, which the data sheet will tell you more about. The Hall sensor we're using for this project is, okay, now actually on the Hall sensor printed there it says 44E402, so we need to mount that somewhere like that. And like I say, it needs to go within a certain distance, and obviously if you search for the data sheet on your particular Hall sensor, you'll be able to find out the minimum and maximum distance from which it will detect a magnetic field. Okay, I've decided on, this is a scrap piece that I cut off so that I could mount this on there. I think it came off one of these sides or that side. But I have decided that we are going to trim this piece off, that piece there with the little blue tab on it, and then we are going to use the glue gun and mount it somewhere along there, which will allow me to, obviously when I trim that tab down, will allow me to mount it close enough to the Hall sensor to detect the magnetic field. And then I will just use a spot of glue from the glue gun on the bottom of this board and affix it to there. I've trimmed that tab off. I've also trimmed these edges down just to make it a little bit more of a neater job, shall we say. And then what I shall do is get the glue gun out. I will double check first that everything's going to line up properly, which yes it is. I shall get the glue gun and I shall glue this piece of plastic to this piece of plastic. Obviously when the motor spins, the magnet will pass under the Hall sensor and the Hall sensor will be able to detect it. I'll apply a fairly liberal amount of glue from the glue gun rather quickly. That should do, and then fix that there. Just make sure it all lines up. A little bit more glue down there to make sure that it doesn't move. Now to attach the Hall sensor. To do that, all I'm going to do is fill this cavity with glue. I'll mount it there like so. And the good thing about using the glue gun is that if I need to take that sensor off for any reason, it will just come straight off because the glue is not very strong. It will hold it for the purposes of what we want to do, but if I need to remove it, it will come straight off. The good thing about taking, say, old CD drives apart to complete your project is there's a whole wealth of parts you can pull out of them. We've got a switch, an LED. I did want to grab the laser, but I managed to break it trying to get it out. Stepper motors, 12 volt AC stepper motor, and there's another 12 volt AC stepper motor there, and these are 12 volt AC 3-phase. So you do actually need a driver board to drive them, or a controller board to drive them. I'm not really 100% sure how we would wire that one up. However, I do know that this one has got 4 pins. You could just unsolder those. You know, one will be ground, and then 3 will be plus 12 volts AC. So fairly easy to take them out. Just undo those 2 screws there. Perfect for a 3D printing project, especially soon as though it's got the cog on it. And if you save all the little plastic parts out of the CD that make the laser array move backwards and forwards, you know, you could make a little miniature 3D printer. You need one for this axis, one for that axis, one for the up and down axis. Okay, I have connected the positive and negative wires to the motor. It's just a 5 volt Nokia mobile phone charger, an old one. Chopped the end off and attached it. And we will now see whether or not this 5 volts, in fact let me double check it is 5 volts. It is 5 volts, 450 milliamps. So we will see if this is enough power to spin the motor before we go any further. Brilliant. Okay, now we will try reversing the polarity, see if we can get it to spin clockwise. So obviously this is how it used to work in the CD drive. It hit a limit switch, and when it hit the limit switch it would stop, and then when you press the button to put the CD tray back in, obviously it would spin the opposite way. There we go, and now it's spinning clockwise. So DC motor can be powered either way. It doesn't really make any difference which one's the positive and which one's the negative. So all that dictates is the direction of travel. Okay, what I'll do now is I'll make these connections to the motor a little bit more permanent, and then we are almost at the point where we can connect the Hall sensor up to the Arduino and monitor the output. But for now we will test the concept by connecting the 5 volt 450 milliamp power supply to the positive and negative wires for the motor, and then we will connect the Arduino and monitor the output. So to start with, we'll just tin the positive and negative wires go to the motor. And this will just make it easier for us to connect the wires to the power supply. There's one. Second. Now I will just pin the wire to the power supply, and then we shall connect it up. One wire. Two wires. And now I shall add a little bit of insulation tape. So just for safety's sake, we shall insulate these wires. Probably won't be a very pretty job. However, it makes things nice and safe. I shall connect the Arduino Uno up. Now on this particular Hall sensor, this pin is the signal, the middle pin is the 5-volt input, and the left pin is the ground. So now we will go ahead and plug the Arduino into the computer. And we shall have a look at the code. And we shall plug power supply to our motor in. Now, I don't know whether you can see on the video, you can if I do that. You see how the light on the Hall sensor is flashing? That means that it is picking up the magnetic field. Okay, now we've had a look at the circuit working, we're going to put a potentiometer here so that we can adjust the number of revolutions per minute. We will first put the potentiometer in on the 5-volt power supply. I will provide a link to the circuit diagram in the description. Also, there is a link to the code in the description. Okay, I've now wired a, you can see, like 10k resistor into the circuit. So we have now got some kind of control of the speed of the motor. I will now connect back up to the Arduino and we will see what kind of output we get now. Okay, so here's the completed circuit. 10k potentiometer here, our motor, and our Hall sensor connected to our Arduino. Potentiometer lets us control the speed of the motor so we can get differing values when we read with our Hall sensor.